Good afternoon, everyone. I'm Ayush Srivastava, and I'll be presenting a paper, Post-Surgery Stability Analysis of Scaphoid fractures. Let me start by introducing the scaphoid bone to you. Scaphoid is one of the 8 carpal bones present in the human wrist. It is located at the base of the thumb, and it's approximately the size of a cashew nut. It is prone to fractures and usually happens when a patient falls onto an outstretched arm. Additionally, the scaphoid bone has blood supply from the radial artery, which provides an adequate amount of supply to the distal pole, but an insufficient supply of blood to the waist and the proximal pole. Statistically, 70% of the fractures are at the waist of the scaphoid bone. Moving towards the surgical treatment of the scaphoid bone fractures, the surgery is used to treat scaphoid fractures using 2 implants, a K-wire and a Herbert screw. The K-wire is just a wire made of stainless steel, whereas a Herbert screw is a specifically designed implant made of titanium with varying pitch, which creates a compression effect when it is drilled into the bone, making it ideal for non-union fractures. Now, to create all this in finite element analysis, we needed CAD models. Thus, we took a CT scan of a healthy patient and constructed the CAD model of a scaphoid bone. Additionally, we borrowed some implants from orthopedic surgeons, and through precise and accurate measurements, we constructed their CAD models of the Herbert screw and the K-wire. Before proceeding with our study, we wanted to study how the fracture forms in a scaphoid bone. Thus, we did an impact force calculation in which we calculated 2 loads for a person who slips while he's walking and a person who falls from a stationary motorbike on 2 loads, 1600 newtons and 4000 newtons. Between these loads, we applied forces on the scaphoid in a finite element model and found that the fractures almost always formed on the waist. Thus, we proceeded with our study, assuming waist fractures. Now, to create the CAD models for the post-surgery study, we considered 3 scenarios: a scenario in which a screw is inserted, a scenario in which a screw and a wire is inserted, and a scenario in which 2 wires are inserted. For the single screw, we created 6 random cases. For the screw and a wire, we created 3 special cases of 1 path convergence and divergence. Similarly, for the 2 wires, we created 3 special cases, a parallel, convergent, and divergent case. With all these 18 CAD models, we did the finite element analysis study for 2 particular loads. We did the analysis at a tensile load and a compressive load. We noted down the results of maximum deformation and factor of safety for the data analysis. Moving towards the results, you can see the graph. The graph is formed between the total deformation, factor of safety, and the number. We have shown you 2 graphs for the tensile loading and the compressive loading. This is the results for the single screw surgery. You can see that almost all of the cases show that the factor of safety is very near or below the least factor of safety line for the tensile loading. Even though in compression, it is considerably better, but we considered the screw case to be not adequate for surgical treatment of patients. Moving on to the screw and wire surgery, found out that it was much better than the single screw surgery. And only 1 case was found which falls below the line of least factor of safety. This is the case of convergent implant insertion. Thus, we conclude that the convergent case should not be used by surgeons for surgery. Finally, for the 2-wire surgery, we found that it is an outlier and should never be used, but as you can see that it gives a very high deformation and a very low factor of safety in one particular case. That is the case in which the implants are accidentally inserted in the parallel configuration. So this configuration creates a scenario in which there is no restrictions on the 2 parts of the bone and the bone flows freely. Finally, towards a conclusion, we found out that the single screw is not adequate. The 2-wire case should be avoided at all costs, and the single screw and single wire case is very good for the surgery. And we recommend that you use a parallel configuration or a divergent configuration, which will give the maximum post-surgery stability for the scaphoid bone fractures. Thank you.